Hi class, welcome to our next how-to video. In this video I'm going to show you how to calculate measures of variability, the range, and the standard deviation. I'm also going to show you how to create a new frequency polygon, and in this graph we're going to insert z-scores below the horizontal axis. And with this graph we're going to be able to calculate the z-score for a specific subject and then convert that z-score to a percentile value. The data that we're going to be working with today comes from a knee extension muscle strength test. Like some of the other tests we've talked about in previous videos, this muscle strength test, is commonly performed in the clinic. It's a safe test to perform, and therefore, because of that, it's been used on younger adults, middle-aged, and older patients. To kind of give you an idea of what this test looks like, I've got a research article. Here it is, and here's a picture from that article. And this article here is actually from our lab. And in this test, this knee extension muscle strength test, you have the subject sitting on a cushioned table or a chair, such as the picture shows. And then what you do is you have the subject extend their leg at the knee as hard and fast as they can for about 3 seconds. And from this test, we measure how much force or torque that subject can produce. Torque is a type of force, and that's the strength scores that we're going to be using in this assignment today. Torque values, those are the muscle strength values. The more force, the more torque a subject can produce, the stronger, the healthier that subject is. Similar to previous assignments, the assignment that I'm going to work today is going to be data that's different than the data in your assignment number 3. The data that I'm going to be using today is knee extension muscle strength data, but it comes from young female athletes. The data in your assignment 3 is knee extension muscle strength data, but it's in a different group. It's in middle-aged women. And so different data, but in this video I'm going to take you through assignment 3 and work the exact same problems that you're going to have on your assignment with your data. And so you'll understand the procedures, how to do things. Just the only difference is the data that we're using. I'll be using different data than what you have in your assignment 3, so again, just keep that in mind. Okay, so that's a little background on the knee extension muscle strength test. Again, these muscle strength scores that we're going to be looking at today, they're actually torque values, like I said earlier. And again, the higher the torque, the better the score, okay? The stronger that patient is. And so again, keep that in mind as we work with these data here today. Let's go ahead and take a look at the assignment. Similar to previous how-to videos, I have the Word document assignment on the right side, and I have the Excel sheet on the left side. That way we can look at both simultaneously. For assignment 3, just like every other assignment, let's go ahead and before we get started, type in our name at the top left corner of the page. And again, like I pointed out earlier, the data that I'll be using in this video is from knee extension muscle strength test in a group of young female athletes. Your data is different. Your data, it comes from the same test, but in middle-aged women. So again, keep that in mind. We're going to use these data that's provided for us here on this first page to answer the questions. Okay, let's go ahead and scroll down. Obviously, here's the data here that we're going to use today. Let's scroll down to the first question. What does it say for us to do? It says copy and paste the subject number and muscle strength scores into an Excel spreadsheet. So let's go ahead and do that. Let's take the subject and muscle strength scores, highlight them with our mouse, copy, and then let's go over to our Excel sheet and paste those in our Excel sheet. And I'm going to widen the cells, that way you can see the values and the labels in their entirety. It says the subject numbers should be in column A. Okay, they are. And the muscle strength scores should be in column B. And yes, they are. Good. Arrange the muscle strength scores in order from smallest to largest. Okay, aka ascending order in column D. Alright, so this is similar to the last how-to video, the last assignment. We're going to do the same thing again. We're going to sort these muscle strength scores in order. To do that, it's fairly simple. I'm going to start here in column D because it tells me to, and I'm going to start in cell 2 with the data. I'm going to highlight that cell. I'm going to go to function. I'm going to go to sort. Remember, that's the function that we're going to use in order to sort the data into ascending order. Sort, click OK. Click, highlight all the muscle strength scores, and then click OK. Voila, we've got all of our data points now arranged in ascending order. Cool. It says the last thing here, label this column in order. Okay, so that's why I started here in cell 2 to save space for the label. It says in the problem we're going to label this column in order because the data is in order in this column. I'm going to bold it, okay, just like it is here in the instructions. And it says once we're finished, then we can copy and paste column D as a picture in the space below. Okay, so I'm going to click, highlight all of this, okay, including the label, copy, and then come down here below my problem, right click, go to paste, go to picture. Because we're working with a fairly large data set, you'll notice, and I believe it's the same for your data in your assignment 3, notice that we have 36 subjects. I believe in some of the past videos we haven't had that many, maybe like 20 or 24 subjects. So our data set is quite a bit larger than it has been in previous how-to videos. Therefore, we might have to make this a little bit smaller in order for it to fit on that first page underneath question 1. And so you can highlight the picture here of the spreadsheet of data, and then you can go to picture format, and then you can decrease the size. There we go, perfect, just like that. And so that way the entire picture of the data fits right underneath question number 1 on this same sheet. Perfect, that looks good. Okay, now that we have these data in order, let's go ahead and move on to question number 2. Question number 2 says calculate the mean and standard deviation for this set of data. Round your answers to the nearest whole number. Okay, so we can do that on our spreadsheet here. I'm going to zoom out just a little bit. So you can see I'm going to record these statistics down below our data. I'm going to write in the label mean, also to SD for standard deviation. I'm going to bold these, and then I'm going to use Excel to calculate them. The mean we calculated in the last how-to video. In order to calculate the mean, you can highlight the cell adjacent to the mean just like I've done, and then go up to function. Remember, the mean is the average of the data, so you can type in average. Okay, there it is. Click OK. And then all you have to do is click and highlight all of the data points in the column, and then click OK. Okay, perfect. We get a mean of 140. Let's do the same thing. Let's calculate the standard deviation. The standard deviation, remember, that's a measure of variability. More information is provided in the PowerPoint, so please take some time and review and study that PowerPoint and take a look at standard deviation. In the PowerPoint, it talks about how the standard deviation is fairly difficult to calculate by hand. That's why it's definitely a better way to go calculating the standard deviation in Excel, and so I'm going to show you here how to do that. It's faster, it's more accurate, and again, we have access to Excel, so let's take advantage of that and use it here. So similar to the mean, I've highlighted the cell next to the standard deviation. This is where I'm going to do my calculation for standard deviation. I'm going to go up to function. And then standard deviation, it's actually already in my main list of functions up here, but it's this one. And so if you don't have that in yours in your main list, you can search for it, but it's STDEV. Okay, that's the function for standard deviation. You can hit go, and then yeah, it's this first one here, STDEV. Click OK, and then similar to the mean, click, highlight all of the data, and then click OK. All right, perfect. We've got our standard deviation. Now remember, in question 2 it says round your answers to the nearest whole number. The mean is already rounded to the nearest whole number, 140. The standard deviation, you'll notice all these decimal points here. Let's round this to the nearest whole number. To do that, we can actually use Excel. If you highlight the cell with the standard deviation calculation, just like I've done here, and you go up to the top under the Home tab, if you go to this function right here, decrease decimal, and click it, you'll notice in the cell that the decimal places are decreasing, and I'm going to do it all the way until I get to my whole number. Okay, and in this case, the standard deviation rounded to the nearest whole number is 10. Okay, standard deviation is 10. All right, now that I've calculated my mean, I've calculated my standard deviation, let's go ahead and input those values into our assignment 3. Mean 140, standard deviation 10. Again, I pointed this out earlier. Remember, your data set is different than mine, and so it is possible that these values may be different as well. Okay, again, they could be the same, right? But they could be different, so again, keep this in mind. Okay, now we've calculated our mean, our standard deviation. Let's go to the next question, question 3. What are the minimum and maximum values and the range for this data set? Okay, minimum, maximum we've actually already calculated before, if you remember, in previous videos. So let's go ahead and put those labels below the mean and standard deviation, just as I'm doing here in my spreadsheet. And I'll bold these as well. Remember the minimum, that's the smallest value. So here's our minimum right here. Let's calculate this one first. Highlight the cell next to minimum, go to function. And remember, minimum, to calculate it in Excel, it's the function min. Click OK. Click, highlight all the values, and click OK. All right, so we get a minimum value of 110. Let's do the same thing for maximum. Highlight the cell, go to function. Remember, the function for maximum is max. So if we need to search for it, we can. There it is, max. Click OK. Click, highlight all the data points, and then click OK. We get a maximum of 170. The range is a new measure along with the standard deviation. Again, for more information on the range, please refer to the PowerPoint. The range, how do we calculate it? It's very simple. All it is the difference between the maximum and minimum scores. So we've already calculated the maximum and the minimum here. All we have to do is take the difference between those two, the maximum minus the minimum. To do that, we can actually use Excel, and we can actually do it right here in the cell. We can actually input our own formula, our own function to do this. So I'll show you here how to do that. We've highlighted the cell next to range. I'm going to click on my equal sign on my keyboard, and then I'm going to click on the maximum value, and then I'm going to hit my minus button on my keyboard, and then I'm going to go and click on the minimum value. So we've basically manually inputted a formula into the cell where we're taking the maximum value minus the minimum value to get the range. Once we've done this, hit enter, and then voila, we've got our range. Okay, again, remember the range is just the difference between the maximum and minimum scores, and we get a range of 60. Okay, now that we have our three values here, let's go ahead and input them for question number 3. Minimum was 110, maximum 170, range is equal to 60. Okay, very good. So in these questions here, 2 and 3, we calculated the standard deviation up here in question 2, the range in question 3. Remember, these are both measures of variability, which was the main theme of this PowerPoint. Which one is better to use? It talks about this in the PowerPoint. It's the standard deviation. The standard deviation is a more accurate variable to describe the variability of a data set. Okay, let's go ahead and move on to question number 4. Question 4 says, arrange the muscle strength data into a frequency distribution. Type in the muscle strength scores in column E and the number of subjects who received a given score in column F. If you remember in question number 1, I had you arrange the data in order, ascending order. The reason I had you do that for this particular assignment here is because of this question. Okay, it asks us to create a frequency distribution, which we've done before in previous videos if you remember. When we have a data set that's a little bit larger like we do this week for this assignment, it's a little bit easier to create a frequency distribution when we have the data in order like this. And so that's the reason why I had you put the data in order, in ascending order, is because it's a little bit easier to work with when creating a frequency distribution like it asks us to do in question 4. Okay, it says type in the muscle strength scores starting with the smallest value in column E. So let's go ahead and do that. I'm going to start here in cell 2. The reason why, again, I'm going to put my labels here in these top cells. So starting here, cell 2E, I'm going to start with my smallest value. And again, we can use these data in order, these muscle strength scores in order to help us create this frequency distribution, starting with the smallest, which is right here, 110. The next value is 120. The next is 130. Then we have 135. Then we have 140, 145, 150, 160, and 170. Okay, so yeah, that's all the scores here in our data set. Now in this column, it asks us to count the number of subjects who received a given score in column F. And so starting here with this first value, 110, how many subjects scored a 110? Well, if we look at our data set here, only one, right? One score, so I'm going to input a 1 here. 120, only one subject scored a 120. What about 130? 1, 2, 3. 3 subjects scored 130. What about 135? 1, 2, 3, 4, 5, 6, 7, 8. 8 scored 135. What about 140? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 subjects scored a 140. 145. 1, 2, 3, 4, 5, 6, 7, 8. 150. 1, 2, 3. 160. Only one subject scored 160. 170. Only one subject scored 170. All right, great. Now it says in question number 4, insert labels at the top of each column. Label the first column X. Okay, so I'm going to type in an X here in this first column. And then it says in the second column, label that F. And I'm going to make both of these bold, okay, like it shows in the instructions. For the F, I'm also going to italicize it just like it is here. And then also too, I'm going to shift these labels to where they're directly over the values. In order to do that, we did something similar in the previous videos. In order to do that, if you go to the Home tab, go to Align Right, click on it, it aligns those labels directly over the values. Okay, that looks good. Once finished, copy and paste your frequency distribution as a picture in the space below. Make sure it's large enough for me to see. Okay, I'm going to zoom in here a little bit. Copy our frequency distribution. And then I'm going to paste it right underneath as a picture. It says make it large enough for me to see. I'm going to highlight this. Notice how it's fairly small here. I'm going to highlight this. I'm going to go to picture format, and then I'm going to increase the size of the frequency distribution. There we go. That looks good. Okay, great. Now that we've created our frequency distribution, let's move on to question 5. Question 5 says, use the frequency distribution data to create a frequency polygon graph. So similar to previous videos, we're going to create a frequency polygon graph using these data here, our frequency distribution data from question 4. Let's go ahead and do that. In order to do that, we can highlight the values. We don't have to highlight the labels. We can just highlight the values here in our frequency distribution in Excel. And then we can go to Insert, go to Charts, go to Scatter, and then go to Scatter with Smooth Lines and Markers. All right, very good. Now we've created our frequency polygon graph. There's still several things that we need to do. The first thing it says, include labels for both the horizontal and vertical axes. So let's go ahead and do that. Let's highlight the horizontal axis first. Go to Chart Design, go to Add Chart Element, go to Axis Title, go to Primary Horizontal. It says make the horizontal axis, label it Muscle Strength Score. So I'm going to type in Muscle Strength Score. I'm going to highlight this. I'm going to go up to the Home tab. I'm going to change the font to black. I'm going to bold it, just to make it a little bit more visible, easier to see. Let's do the same thing. Let's create a axis label for the vertical axis. To do that, click on the vertical axis, highlight it, go back up to Chart Design, go to Add Chart Element, go to Axis Titles, go to Primary Vertical, and it says for the vertical axis we're going to label it Frequency. Highlight that, just like we did with the horizontal axis, change the font color to black, bold it, and then like in previous videos, I'm going to click and drag this to make a little bit more space in between the axis title here and the values. Just makes it look a little bit better. Okay, now that we've created our axis titles, next step, remove the title. Okay, let's go ahead and do that. Click on the title, and then on your keyboard, click Delete. It also says delete all horizontal and vertical grid lines. If we click on the horizontal first, highlight those, and then click Delete on our keyboard. Good. Let's do the same thing with the vertical grid lines. Click, highlight, and then click Delete on your keyboard. Okay, good. We've removed all of the horizontal and vertical grid lines except for the axes. Obviously, we want to keep the vertical and the horizontal axes there. It says next step, make the line black. Okay, so here's our line that was created in the graph, our frequency polygon. Let's highlight that, right click, go to Format Data Series. Move the graph a little bit so you can see here. There we go. Click on the graph, right click, Format Data Series, and then go to Paint Bucket, go to Line, go to Solid Line, and then go to Color, and then change it to black. Alright, cool. So now we've made our line black. It also says include markers. The markers are already included, okay, when we created the graph, so that's good. However, the markers, they need to be black circles. As you can see, they're blue. In order to change them to black, click on them, highlight them, right click, Format Data Series, go to Paint Bucket, go to Marker, go to Marker Options, go to Built-in. Make sure this is selected. It already is, but this is the circle icon marker, okay, which is what we want. Good. The size is already set for us at 5. Okay, that's good. Let's go to Fill next. Fill, we need to change these markers to black. So click Solid Fill, go to Color, go to Black. There we go. One last thing. It says with no border or outline for the markers. So to remove the border, to remove the outline, if we go to Border next, and then we click on No Line, that removes the border from the markers. Good. Okay, that looks good there. Next step, insert major tick marks on the outside of both axes. Let's start with the horizontal first. Click on the horizontal axis, highlight it, right click, format axis. Go to axis options, go down to the very bottom where it says tick marks. Click on tick marks, go to major type, that's what we're adding, and then go to outside. All right, good, it's added tick marks. Let's do the same thing for the vertical axis. Highlight the vertical axis, right click, format axis, go to axis options, tick marks, major type, outside. Good. Now we've added tick marks at each value on our axes. Next step, for the horizontal axis, make the minimum bound value 70 and the maximum bound value 130 with major units of 10. Now remember, just like in previous videos, my data is different than yours, and so I'm going to, because of that, I'm going to make my bounds different than what it states here. These are instructions for your assignment, assignment number 3. So again, make sure and follow those. Okay, remember, one of the things that I'm grading you on when you do these assignments, not only are you getting the correct answers, but also too, I'm giving you a grade on how well you can follow instructions on questions such as this. And so make sure when you're doing your graph here in question number 5, follow these instructions exactly the way that I have them here. And so these minimum and maximum bounds, these are for your data set. However, because my data is different, I'm going to have different bounds. Remember, a good rule of thumb is we can use the minimum maximum values as our minimum maximum bounds. If you remember, I'm going to scroll down on my Excel sheet just a second. We already calculated the minimum maximum values. The minimum was 110, the maximum was 170, so that's what I'm going to set it to here in my graph. I'm going to set the minimum value, and again, all you have to do is highlight the axis, right click, format axis, go to axis options, bounds right up here. I'm going to change my minimum value to 110, and then I'm going to change my maximum bound value to my maximum value, which was 170. And then it says make sure you have major units of 10. If we look at the units, yep, they're already set there for us at 10, so we don't need to change that. That's already set for us. But again, with your data, if you do need to change the units, make sure they are set at 10, these major units of 10. Again, all that means is that there's just 10 units in between each value. Okay, let's move on. For the vertical axis, make the minimum bound value 0 and the maximum bound value 11. Okay, so to do that, to change the axis in the vertical, let's click on it, right click, format axis, go to axis options. The minimum bound value, it says, needs to be 0. It's already set there for us. Good. The maximum bound value, it says for us to change to 11. So let's go ahead and do that. Okay, good. However, did you just see that? Did you notice that when I changed the maximum bound value to 11, Excel automatically changed the minimum value to -1? You'll see that there. Sometimes Excel does that. When you change one bound, it'll change another. But again, we need to follow the instructions here in question 5. And it says for the vertical axis, we need to make sure that the minimum bound value is 0. So we need to manually change this back to 0. So click on it, click 0 on your keyboard, and then yeah, you can change it back to 0. Good. It also says that for the vertical axis, we need to have major units of 1. Notice what are our major units here on our vertical axis. Yeah, you can see it over here in the graph. You can also see it under units as well. The major units are set at 2, right? There's 2 in between each value. We need to change this to 1. So let's go to units major, highlight this, and then change it with our keyboard. Type in 1 for our major units. Now if you look at our vertical axis, now you can see that, yeah, there's 1 unit in between each value. Good. Okay, the next step here it says, and these are these next steps are new steps, new procedures that we haven't done previously in previous videos. Some of these steps that we did up here, we've done several times already, but starting here, these are new steps. And so yes, pay particular attention to these here as we go through them. It says here first, minimize the size of your graph to create more space below the horizontal axis. So eventually what we're going to do here is we're going to add z-scores to this graph. But notice how there's not a lot of space underneath the raw muscle strength scores. There's not enough space to add z-scores. And so to create more space, how do we do that? Well, I'm going to show you here. If you click, like I've done here, to where the inside of the graph is highlighted, do you see that? Okay, see how we have the border highlighted? Okay, if you do that, and then with your mouse, like I've done, if you go to the horizontal axis here, and you go to the middle dot here, left click and hold, and then slowly move up the axis. I would move it up to about here, okay, to where it's in line with that 2 right there. If you can see the dotted line and see how it's in line with the 2. And then release. And obviously notice what's happened. Yeah, we've basically created more space, right? We've created more space below the horizontal axis. Now we can input our z-scores below. Okay, so now that we've created more space below the horizontal axis, the next step says insert a text box, no fill, labeled z-score. Okay, so to do that, we're going to click on our graph to where it's highlighted. See the border, it's highlighted. Go up to the top, go to insert, go to text, go to text box, and then inside your graph you can create a text box like I'm doing here, and then you can type in z-score. Once you've typed that in, I'm going to move it to where it's in the middle. I'm also going to decrease the size of the text box to where it's just large enough, okay, for it to fit the text in. I'm also, while the text box is highlighted, if you take a look over here, the next step it says labeled z-score, font size of 10. If you look here with the box highlighted, and if you go up to the top to the Home tab, here is the font. Okay, the font is fine. We don't need to change that, but here's the font size. Notice that it's set at 11. The instructions specifically state we need to change this to 10, so let's do that. So go up here and then go to 10. Okay, makes it a little bit smaller. Also too, notice how it's bolded here in the instructions, so let's bold the z-score. Okay, good. Again, change the size of my text box so it's just large enough. I'll do that here too on the bottom, so where it's just large enough in order to fit the text in the box. Now that we've done this, it says place this text box labeled z-score directly below the muscle strength label. And so I'm going to click with my mouse and drag to where this z-score is directly below the muscle strength score, right here in the middle of my graph. Perfect, that looks great. Okay, now that we've done this, let's move on to the next step. It says create additional text boxes for each z-score in the graph and position them directly underneath the corresponding raw muscle strength scores. Okay, so we're going to create a new text box. So again, make sure the graph is highlighted first, then go up to insert, go to text box, create a new text box, and then inside the text box we're going to add z-scores. Okay, we're going to add z-scores to the graph, and so we're going to type in the z-scores for each raw score in the graph. In order to do that, let's start with the first z-score. Let's start with a z-score of 0. So I'm going to type in 0 into my text box. Again, make sure the text box is just large enough, okay, for it to fit the number in the box. Also too, take a look here in the instructions. It says no fill, okay, and it also, if you remember, it said no fill up here. What does that mean? Well, all that means is that if we highlight the text box like I've done here and we right click, go to Format Object, if we go under Paint Bucket and go to Fill, you'll notice that it's already actually selected for us as no fill. If we go to Z-score, we can check and make sure that it's also no fill as well. Yeah, if we highlight it and if we go to right click format object, we'll also notice that, yeah, the Z-score text box that we created earlier also is no fill, which is what we want, which is what the instructions tell us to do. So, yep, so that's all good right there. It also says no fill, no bold. Okay, so we don't need to bold these values. To make sure that they're not bolded, you can highlight the value as I've done here and then go up to the Home tab. Make sure that the bold icon isn't selected. It isn't, so we're good there. It also says change the font size to 9. Notice how I have the text box highlighted. If we go up to Home, again, the font is fine, but the font size, notice that it's set at 11. We need to change this to 9. The instructions tell us to change the Z-score text boxes to a font size of 9. Okay, now that we've done that, now we need to position these Z-scores directly underneath the corresponding raw muscle strength values. So a Z-score of 0, where are we going to place this on our graph? If you take a look at the PowerPoint, it goes into detail on this topic, Z-scores. A Z-score of 0, that corresponds with the mean value, with the mean raw score value. So what was the mean raw score value? Do you remember in our example from earlier? We calculated it. The mean raw score muscle strength value was 140, right? Right here in the middle. Again, what have we created here? What does this look like? What type of curve? Yeah, this is a normal curve. And so this frequency polygon that we've created, it is a normal curve. And a classic characteristic of a normal curve is that the mean is located right here in the middle. And so, yeah, sure enough, yeah, 140, that was the mean that we calculated earlier in this example. That is the raw muscle strength mean score. So, yeah, based upon the PowerPoint, we know that a Z-score of 0 corresponds to the mean. And in this case, the mean is 140. So I'm going to place this Z-score of 0 directly underneath the raw mean score, muscle strength score that it associates with. Okay, so yeah, a raw muscle strength score of 140 in this example corresponds, is equivalent to, okay, is equal to a Z-score of 0. All right, let's go ahead and create another Z-score. In order to do that, let's highlight our text box and then right click, go to copy, and then we can go to paste, right click and paste. Okay, notice how we've pasted a new text box. It appeared right here in the top left corner. We can click and drag this back down to where we need it to be. Let's start with a Z-score of, or let's do a Z-score next of +1. And again, you might have to adjust the size of the text box in order for the value to fit inside, in order for it to be visible. So where are we going to place this Z-score? A Z-score of +1. Again, please refer to the PowerPoint. It goes into detail on Z-scores. What do Z-scores indicate? Basically, they indicate how many standard deviations the raw values are above or below the mean. Okay, I'll say that again. The Z-scores, what do they indicate? They indicate how many standard deviations the raw score is above or below the mean. And so, for example, +1 here. Okay, basically this means what? This means +1 standard deviation. That's what a Z-score +1 means. Okay, it means 1 standard deviation above the mean. And so we know the +1, okay, where are we going to put the pluses? We're going to put them to the right. Why are we going to do that? Because, yeah, these values here are all above the mean. +1, that means 1 standard deviation above the mean. So, yeah, we know we're going to put these plus values here for our Z-scores to the right of the mean Z-score, which is 0. Now, if you refer, or if you go back in earlier in our example, we calculated the standard deviation. Do you remember what the standard deviation was? The standard deviation for the raw muscle strength scores was 10. And so a Z-score of +1, what does that mean? That means 1 standard deviation above the mean. So how many units are we going to go above? Yeah, if 1 standard deviation in this example equals 10, then we're going to go +10 above the mean, Remember, the mean is 140, so if we go plus 10 of 140, what does that give us? 140 plus 10 is equal to 150. So that's where we're going to put the z-score of plus 1. Okay, it corresponds to a standard deviation of 1. Okay, 1 standard deviation above the mean. Where is that located? Yeah, it's located right here, directly below the raw score of 150. Okay, a raw score of 150 in this example corresponds with a z-score of plus 1. Okay, they are equal to one another. Okay, let's go ahead and create another text box. Let's do plus 2 next. Where are we going to put the plus 2 z-score? Well, similar to this one, plus 1, plus 2, what does that mean? That just means 2 standard deviations above the mean. Okay, instead of 1, now we're doing 2. 2 standard deviations above the mean. Again, 1 standard deviation, we calculated that earlier in this example, is equal to 10. And so 2 standard deviations, how many raw values would that be? How many raw units would that be? If 1 standard deviation is 10, how many would 2 be? 2 standard deviations would be 20. Okay, all we have to do is just multiply, okay, the z-score by the standard deviation. In this case, a positive 2 times the standard deviation, 10, is equal to 20. And so we're 20 raw score units above the mean. So what's 20 plus 140? Remember that 140 is the mean. So 140 plus 20, that's 160. So yeah, a raw score of 160, that is equivalent to a z-score, a corresponding z-score of plus 2. So that's where I'm going to position my text box here, directly below the raw score that it corresponds with, in this case 160. I'm going to move this just a little bit to where it's directly below there. Okay, good. Let's go ahead and create another z-score. Okay, I'm going to drag that down. Let's do a z-score of 3. Where are we going to put this one? Well, again, a z-score of plus 3, what does that mean? That just means 3 standard deviations above the mean. 1 standard deviation is equal to 10. How many units would that be for 3 standard deviations? Well, 3 times 10 is 30. And if we go 30 plus 140, what does that give us? Yeah, that equals 170. So that's where we're going to put the plus 3 z-score. Okay, the plus 3 z-score indicating 3 standard deviations above the mean, okay, which corresponds with this raw score of 170. 170 is equivalent to, in this example, a z-score of plus 3. Okay, good. Let's go ahead and continue. I'm going to copy and paste and create a new text box. Now let's do a z-score of -1. Okay, where are we going to put a z-score of -1 in our graph? Similar to the positive z-scores, the negative z-scores, what does that mean? That just means how many standard deviations below the mean the raw score values are. And so for this one, a z-score of -1, what does that mean? That just means 1 standard deviation below the mean. Okay, remember the mean here is 140. 1 standard deviation, we calculated that earlier, the standard deviation is equal to 10. And so 1 standard deviation below the mean, okay, all it is 140 minus 10, which is equal to 130. So that's where we're going to put our z-score here of -1. It corresponds, it's equivalent to a raw muscle strength score of 130. Okay, let's copy and paste. And let's create another z-score. Let's create a -2 z-score. Okay, where are we going to place this z-score in our graph? Yeah, this -2, what does that mean? That just means 2 standard deviations below the mean. 1 standard deviation is equal to 10. 10 times 2 is 20. If we take 140 and we minus 20 from it, what does that give us? 140 minus 20 is 120. So that's where we're going to put the -2 z-score. It corresponds with a raw muscle strength score of 120. Last one. let's do a z-score of -3. Okay, a -3 z-score, what does that mean? That just means 3 standard deviations below the mean. 1 standard deviation is equal to 10. 10 times 3 is 30. The mean is 140. 140 minus 30 is equal to 110. So this right here is where we're going to put our -3 z-score. Okay, directly below the raw muscle strength score of 110. Again, and you probably noticed this when I was inputting these scores, try to make sure also not only that they're aligned, okay, with the raw muscle strength scores as I've done, but also make sure that they're in line with one another, okay, horizontally. And it looks like that they are, okay, but yeah, to make sure that the graph looks as best as possible, make sure that all of these scores are as best you can in line with one another. And it looks like they are. I might move this up just a tad here. Okay, cool. All right, very good. So what we've done, yeah, is create those additional text boxes. Again, we followed the instructions exactly for each z-score in the graph. Again, and for this particular graph here, and in most normal curves, it talks about this in the PowerPoint, in most normal curves, most normal distributions, especially when we have a large data set, yeah, we typically have a total of 6 standard deviations or 6 z-scores. Remember, z-scores we just got through talking about, they represent how many standard deviations the raw score is above or below the mean. And so yeah, so if you count them, yeah, we've got 3 to the right and we've got 3 to the left. Okay, and then remember, a z-score of 0, that just indicates where the mean is located. Okay, so yeah, very good. So we've inputted all the z-scores, okay, that correspond with each raw muscle strength score in our graph. Good. Okay, let's go to the next step. It says insert gray straight lines between the curve and the horizontal axis at each z-score. Okay, if you refer to the PowerPoint, you'll see some frequency polygon graphs similar to this, where I have the z-scores below the raw scores. And you'll notice inside the graph, I've got these vertical dashed lines. And these dashed lines are aligned with each z-score in the graph. We're going to do something similar now here. That's what the instructions are basically telling us to do. Instead of dashed lines, though, we're going to insert solid gray straight lines here in this example in your assignment number 3. In order to do that, highlight the graph, okay, to where the border is highlighted, go to Insert, go to Illustrations, go to Shapes, and then you can either find it up here at Recently Used Shapes, or you can go to Lines. It's just this one right here, Line. And then what we're going to do next is we're going to come here. Let's do the z-score of 0 first. Start up here at the top, left click and hold, and then drag and form your line to where it goes all the way to the horizontal axis, which is here. If you need to, you can adjust the line. Also, to take a look at the instructions. It says insert a gray straight line. Notice what color this is. Yeah, it looks like blue to me, and so we're going to need to change that. So highlight the line by left clicking on it, and then right click, go to Format Object, go to Paint Bucket, go to Line, go to Solid Line, and then change the color. Notice how it's set at blue. Change the color to, it says in the instructions, gray. You can select this middle one right here, this gray value that I'm highlighting. Click on that one, and then yeah, you can see that now the line has changed to a gray color. And then the width of the line needs to be set at 0.75. In order to change the width, you can, in the same menu, okay, so after you change the color in the same menu, you can go down a couple spots to width. Notice the width is currently set at 0.5. Let's change that to, the instructions say 0.75, so go up 1 to 0.75. It just makes the line a little bit wider, a little bit easier to see. Okay, and then yeah, that looks good. All right, and then yeah, if you need to, again, you can adjust it, make the line longer, okay, if need be. Okay, again, just try to make it look as visually appealing as possible. Okay, that looks good. All right, let's create another gray line. And again, in order to do that, you can just do exactly what I did. I just clicked on it and I copied and pasted, okay, this line again. Okay, I made basically a duplicate of it here. You can do the same thing. And then now I'm going to take this line and I'm going to line it up with the +1 z-score. Again, you'll do it for each z-score. I'm going to start here with the +1. Again, you'll notice that this is obviously too long, and so we're going to need to shorten it. You can click on it and adjust it, just as I'm doing here. And again, the instructions refer back to them. We're creating these vertical lines between the curve and the horizontal axis. So yeah, that's exactly what we need to do. Make sure that the line, okay, just barely touches the curve, okay, and then it goes all the way down to the axis. Okay, so yeah, make sure and follow those instructions. Again, you can adjust it if need be. Okay, looks pretty good. All right, let's go ahead and create another one. Again, you can copy this line that you just created and then hit paste. And sometimes when you do that and you hit paste, sometimes it appears over here in this top left corner, so just FYI. If you do the function and you hit paste and you're wondering where it went, sometimes it goes up there, so just be cautious of that. I'm going to put this next gray line to indicate where the -1 z-score is, okay, which is right here. Okay, corresponds with this raw score of 130 if you remember. Again, if you need to adjust the line, you can. Okay, let's create another gray line. Okay, I'm going to put this next one here right above this z-score, -2. Again, I'm going to adjust the size of it, the length of the line, okay, to where it just touches the dot. In this case, it just touches the curve and then it goes down to the horizontal axis. Notice over here with the -3 z-score, we already have the axis there, and so because of that, we don't need to create another gray line, okay, where the axis is. The axis is already there, and so yeah, so we don't have to do one for the -3 z-score. Okay, so let's go back over here. Let's copy this line over here and paste. Again, my paste went up here to the top left corner. You can click on it, drag it back over to where it needs to be. Let's put this one now directly over the +2 z-score. Okay, that looks pretty good. And then let's do one more now. Copy, paste, drag it back over, and let's put a gray line now above the +3 z-score. So yeah, so again, why are we putting these gray lines in the graph? They're just they just look a little bit more visually appealing, and they help to indicate where these z-scores are. Again, notice we put a gray line for each z-score, right? And so it just helps to show the reader, the person who's looking at this graph, where these z-scores are located. Okay. Okay, now that we've aligned all of our gray lines with the z-scores, I'm going to make one last change here. Notice how the axis here is a little bit low on the vertical. I'm just going to click and drag, okay, and move it up just slightly, okay, to where it's more in the middle, okay, of this vertical axis. All right, now that we've done that, I'm going to zoom out just a little bit so we can, again, just make sure and see the graph in its entirety here. Yeah, that looks great. If we take a look back at the instructions, it says once we're finished, copy and paste your frequency polygon graph as a picture in the space below. You can either copy it directly from Excel or use the snipping tool on your computer. Remember from previous videos, I believe I've actually showed you both ways. So please refer back to the previous video where I did this. I'm just going to show you one way here. I'm going to use the clipping tool this time in order to take a picture of this, and then I'm going to paste it over here in my assignment. And so to do that, remember, you can just type in your search bar on your computer, snipping tool, click on it, and then click on the try snip and sketch. And I believe I actually already have it pulled up. Yeah, here it is. Okay, and then yeah, it comes to this screen here, and then click new. And highlight the graph. Once you've highlighted the graph, go to copy up here at the top right corner, click copy. And then now you can go over here and underneath question number 5, right click, and then hit paste. Boom. There we go. It says at the very end here, you may have to adjust the size of your frequency polygon graph so that it fits on this page. Make sure it's large enough for me to see. I'm going to make it a little bit larger. To do that, just highlight the graph that you just created, go up to picture format, and then you can increase the size. All right, cool. That looks good. All right, nice. So we've created a frequency polygon graph similar to what we did in previous videos. However, we've definitely added a few things pertaining to the PowerPoint from this week. In particular, we added the z-scores, and then we also added the gray lines inside the graph in order to indicate where these z-scores are located. Looks good. Okay, let's go ahead and move on. And I'm going to go ahead and pull. I've got 2 more questions to go. I'm going to pull them up here so you can see those with the graph. It says for number 6, calculate the z-score for subject number 5. Okay, so let's go ahead and do that. In order to calculate the z-score, this is referring to material that was covered in the PowerPoint. In the PowerPoint, it talks about the calculation of the z-score, and I'm going to pull that up in our video for you to see. Here it is. It shows the equation for the z-score here. Z-score is equal to x, which represents the raw score, minus x with the hyphen above it, that represents the mean, divided by the standard deviation. So this is the equation we're going to use to calculate the z-score in question number 6. So in order to calculate the z-score, what do we need? Well, based upon the equation, we need to know what the mean is. Do we know what the mean is? Yeah, we do, right? Again, we can refer to our frequency polygon that we just created in order to see where the mean is. Remember, the mean corresponds with a z-score of 0. Here's 0. Okay, that's equivalent to a raw muscle strength score of 140. So the mean in this problem is 140. Remember the standard deviation? The standard deviation was 10, right? Okay, and then yeah, remember +1, +2, +3, these z-scores here, all they indicate is how many standard deviations above the mean a raw score is, or the ones over here on the left side, -1, -2, -3, these z-scores indicate how many standard deviations a raw score is below the mean. Okay, so yeah, so remember from earlier, the standard deviation was 10. Okay, so 1 standard deviation is equal to 10 raw strength score units. And so 1 z-score above the mean, okay, is basically 10 units above the mean, 10 units above 140. Okay, so yeah, so the standard deviation is 10. The mean is 140. What else do we need to know to calculate the z-score? We need to know the raw score. How do we find the raw score for subject number 5? All we have to do is go back up to the very beginning of our assignment. Remember the beginning of our assignment, and the assignment provided us with the data? We can find the strength score for individual subjects in this data set, okay, this very initial data set that was given to us in the assignment. So if we go to the very first page in our assignment and we go to subject number 5, which is here, and we look over at subject number 5's muscle strength score, that person had a muscle strength score of 135. So that's their raw score. This is their raw muscle strength score, 135. Okay, and again, remember as we're going through these, remember your data is different, okay? So your subject number 5 may have a different score than my subject 5. So again, just keep that in mind, okay, as you're working these problems out. Okay, your data set is different, therefore it's possible that some of your answers may be different as well. Okay, now that we have everything that we need to solve for the z-score, we know what the raw score is, we know what the mean is, we know what the standard deviation is. Now we're ready to solve. Again, I'm going to pull up that PowerPoint one more time for you to see, okay, the equation for z-score. We can actually use Excel. Similar to what we did earlier with the range, we can actually type in this equation into Excel in order to solve for the z-score. Let's go ahead and do that. You can click on any cell. Okay, I'm going to click on this one here, any blank empty cell. Okay, I'm going to click on this one. In order to input the formula, okay, basically we're going to input this formula here. In order to input that formula, I'm going to hit equal sign. And then I'm going to add parentheses. Now you might be thinking, well, wait, where do the parentheses come from? Well, what I'm putting parentheses in because I want to do the numerator first. Okay, remember above this is the numerator, below is the denominator. I want to do the numerator first, and in order to do that, we need to put parentheses. Okay, so FYI, when we're putting this into Excel like we're doing here, make sure and put this in parentheses first, this numerator part, the x minus the x bar. Remember the x represents the raw score. The raw score in my example, remember we just got through looking it up. Subject number 5 had a raw score of 135, so I'm going to type in 135 here for x. And then minus, right, x minus. Remember the x with the bar above, that represents the mean. The mean in my example is 140. And then I'm going to close parentheses now that I'm done with the numerator. And then the last step is, remember this means divided by. So divided by in Excel is this. Hit this on your keyboard, this slash. That represents divided by. The standard deviation, remember the standard deviation in my problem was 10. Okay, we solved that earlier. Now that we've put that, the equation into the cell, we're ready to go. Click enter, and then voila, we've got our z-score. And so the z-score for subject number 5 in my example is negative 0.5. Cool. So let's go ahead and input this into our assignment. Again, I know I keep saying this, but remember your data is different, and so it is possible that you might have different answers here, okay, in your assignment. So again, just keep that in mind. For my assignment here, my example, the z-score for subject number 5 is negative 0.5. Now, what does that mean? Okay, and again, we can use the graph to help make sense of this. A z-score of negative 0.5, where is that located? Yeah, it's located right here, right? Here's a z-score of 0 where the mean is. Here's a z-score of negative 1. Negative 0.5 is going to be right here in the middle. Okay, so does that make sense based upon the subject's raw score? Yeah, it does. Remember the raw score in my example for subject number 5 was 135. 135 would be where? Right here, right? Okay, on the horizontal axis, it would be right here in between 130 and 140, right in the middle. And that's exactly where the z-score is. A z-score of negative 0.5 is equivalent to a raw muscle strength score of 135 in this example here. And so, yeah, so it does make sense. So again, we can use our frequency polygon graph. We can use this normal curve that we created here in order to answer these questions down below and in order to confirm, okay, that our answers are in fact correct and make sense. Last question, number 7, it says determine the percentile value of the z-score for subject number 5 using the table in PowerPoint 5, slide number 33. Okay, so yeah, obviously we're going to use the PowerPoint again. I'm going to go ahead and pull that up. And then I'm going to scroll down to slide number 33. It says it in the instructions. That's the slide we need to refer to in the PowerPoint. Yeah, here it is. This is the first slide where the table is shown. Like it says in the PowerPoint, each z-score has a corresponding percentile value. And remember, in the example, the value we just calculated, the z-score we just calculated was negative 0.5. And so how can we use this table here in order to locate the corresponding percentile value for negative 0.5? It's really easy to use. If we take a look at, and you can see here the z-score, negative 0.5 over here. If we start with the first digit first in the z-score, so negative 0, okay, that's the first number. That's the first value here in our z-score is negative 0. And so to find that, you start here in the left column and find that first value. So yeah, we got negative 2, negative 1. Here's negative 0 here. Okay, so this is where we are. This is the row that we're going to find our percentile on. The next step is look at the second or the next digit. Okay, the next value, which is 0.5. So the first value is negative 0. The second is 0.5. The points we find up here on the top row, notice 0.0, 0.1, 0.2, and so on and so on. 0.5, okay, which is what we're looking for, is right here. And so what we're going to do is we're going to start here at our first value, negative 0, and we're going to scroll across until we get to that column with 0.5, which would be right here, right? Okay, basically what it is it's the row, we're finding the row, and we're finding the column, and it's where this row and column, it's where they meet. That is the percentile value. Okay, that is the corresponding percentile value for that z-score. So in this particular example here, for a z-score of negative 0.5, the corresponding percentile value is 30.85%. That's the percentile value, 30.85. So cool, so pretty easy. So I'm going to go ahead and minimize this and then input that answer into my assignment. So the percentile, and also to take note, it says here at the end, round the percentile to the nearest whole number. Okay, so yeah, so our value here was 30.85. If we round that to the nearest whole number, what would that be? Again, in this example, that would be 31. Okay, a percentile of 31. Real quick now, again, what does this mean? A percentile of 31, that means that the raw score of 135, remember that was the raw score for subject number 5, a raw score of 135 is equal to or greater than 31% of all the scores in this sample. Is a percentile of 31, is that better than the average score? No, it's not, right? The average score would be right here if we look in our frequency polygon. It would be right here where the mean is. Remember, the mean is 140, okay, corresponds as equivalent to a z-score of 0. This is where the mean is. This is where the average score is. And so negative 0.5, if you remember, is to the left, okay, is to the left of where the mean is located. Okay, and so yeah, and what, again, refer to the PowerPoint for this, it talks about this in detail. What percentile is the mean? What percentile does a z-score of 0 correspond with? It corresponds with the 50th percentile. Okay, the 50th percentile right here in the middle. Percentiles, they range from 0 to 100. So 50, yeah, obviously is right there in the middle. Okay, that's the average. That's the average. That's the mean score, is the 50th percentile. So a percentile of 31 is obviously less than that. Okay, it's not as good as the average score. Any score above 0, above the 50th percentile, is a better score. Remember the z-scores, the percentiles. Why is it important to report these? It's important because they provide perspective. They provide us perspective on how good these raw scores are. So for example, in our example here, subject number 5, a score of 135, that was the raw muscle strength score. If we were to tell a subject this, it's tough to gauge, you know, is that good, is that bad? But when we we report the z-score, and especially the percentiles, most people, lay people, they understand what percentiles are, and so when we tell them what percentile they're in, that makes more sense, and so that gives more perspective to how they did on the test. And so yeah, simply reporting the raw score, usually, typically, that doesn't mean much to most subjects. But when we report the z-score, and in particular when we report the percentile, okay, then that does start to make sense. Then the subject can start to gauge, has perspective on how well they actually did on this test compared to other subject scores. Okay, I think that's it. We've answered all of the questions here. And again, one more thing, I know I keep saying this over and over again, but remember, your data is different, okay? So your answers may be different as well, okay? So again, just keep that in mind here. But yeah, now that we've calculated the percentile, we got the z-score, we've got our nice frequency polygon graph with the z-scores included. We did our frequency distribution, we've got our min, maximum, and range values. We calculated the mean and standard deviation. We placed the data in order, which helped us in creating that frequency distribution. Yeah, now that we've got all of our answers inserted or typed in, you can go back up here to the very top. Again, make sure you have your name. Go ahead and save this. And then after you save this assignment with all of your answers to your computer, then you can go back into Blackboard and upload this assignment with your answers to the Dropbox for assignment 3. Again, I hope this video is helpful. If you have any questions, feel free to shoot me an email. Again, please watch this video. Again, take your time with it. I know I've said this before. If you need to pause the video, and do something, certainly do that, and then you can come back to it later. Again, take advantage of this video. Also take advantage of the PowerPoint too. Please review, please study that. And again, after looking at the PowerPoint, after watching this video, yes, I believe you should be able to answer all of the questions on your assignment 3 with your data successfully. Again, thanks so much. Hope you have a great day. We'll see you next time. Bye-bye.